Hello. How is everybody doing tonight? Good. So, my name is Max. I'm doing actually full-time Clojure nowadays, but I want to talk to you about Golang, WebAssembly, and we're going to try to put together a small front-end framework, like Vue.js, React.js inspired, in Golang and compile it to WebAssembly. Sounds like a good plan, right? So, who here actually knows what is WebAssembly? Yeah? Yeah, to refresh your memory, to introduce you to WebAssembly. WebAssembly is essentially, it's a standard that defines binary instruction format or instruction set. It is intended to be run on sort of a stack machine. Idea was to have something that is faster to parse and execute than JavaScript. And it can be used outside of the browser. Original spec was highly coupled with the idea of browsers, but then later was realized that you don't really have. It doesn't specify how host environment needs to interact with everything that is executed in the WebAssembly environment, right? So to showcase that it's not just about web browsers, there are interesting projects. People already playing with WebAssembly in different applications. So did you know that Cloudflare actually has a serverless platform? No, probably not. Nobody knew, but it exists. And they support WebAssembly. And this is actually a neat hack because they need to support only WebAssembly integration. Everything that compiles to WebAssembly can be now run on serverless platform. And they need to bother only with support of WebAssembly, right? Sounds interesting, sounds simple, kind of works. There's this crazy project actually embedding WebAssembly runtime in Linux kernel. And I think it's like 200 lines of C code, right? Not that complicated. Guy wanted to just do that. His reason for this, he states that the idea was to minimize overhead switching between user space and kernel space and have some sandboxing environment. And it's a good example to actually see how trivial it is to implement WebAssembly stack machine. Right, so what about Golang and WebAssembly? Why is it exciting? So we can now actually use existing ecosystem, existing tooling to build front-end apps, which means we can, essentially, it's backend language moving to front-end development, opposite to what happened to Node.js. And we all know how it went, right? Spoiler alert, not ideal. And we can also share logic between front-end and backend, right? This is neat optimization because you can share exactly the same parts of business logic, do some validation on backend and front-end without duplicating your code, right? And again, we can target not just web browser, kind of, with Go. It's a bit tricky. I'm going to talk about it in a moment. So what about running Go on WebAssembly? It is available since 1.11, which is latest stable release. It adds 2 environment variables to the compiler. You can see Go build command that actually generates test.wasm module. And interop with JavaScript host platform or just with a WebAssembly host platform is done using syscall/js package, which is kind of similar in idea with cgo, right? People familiar with is cgo in Golang? Yeah. It's a sad place to be also. So let's do a hello world example. So
you're brave.
Yeah, live demos, I know, it's scary. So we're gonna compile it as easy as that, and we're gonna actually run our small web server.
Can you make it a bit bigger, actually?
Sorry, don't mind the dog.
Yeah, there we go.
So again, we're gonna just compile it and run our web server. Then we switch to our second tab. The moment I press this button, we're gonna actually stream our WebAssembly module in the browser, initiate our WebAssembly environment, and execute it. And it's gonna show one alert. Amazing. Most underwhelming demo. So there's actually a lot of stuff that is going on behind the scenes. First of all, there are 2 moving pieces that you can find in Go source directory under miscellaneous/WASM directory. There is JavaScript helper and HTML helper. HTML helper is there just to showcase how everything ties together. JavaScript helper is quite a beast. So it unifies Node.js, WebAssembly API, and browser API in one JavaScript object called Go. And then it sets up JavaScript to Golang interop inside of the WebAssembly. Why does it have to do that? Because big chunk of syscall.js package is defined in JavaScript. So JavaScript needs to be able to actually go and change values of pointers inside of the WebAssembly. Right, that's why it's tricky to run it outside of the browser, because you would have to replace this entire integration layer with something of your own, right, depending on the environment. Then to run it, you cannot really load WebAssembly files locally. You have to serve them with content type set to application/WASM. Luckily, we use Golang. We can just create our HTTP file server and just hard code file type. Right, works. So, future of Golang is here. Right, we should be excited. Yeah, it works, but file size, 2.5 megabytes for hello world. This is a lot for a binary format that's supposed to be compact, right? Why is that? First of all, WASM is actually a stack-based machine, so Go has to maintain copy of the entire stack all the time to do garbage collection, for example. WebAssembly is really focused on high-level instructions. For example, there is no GoTo support on WebAssembly. So Go has to generate huge switch statements to switch context between Go routines, which is, again, kind of an overhead. And binary size was not a priority at all for this implementation of WebAssembly in this release. There is a great document called WebAssembly Architecture for Go that outlines all technical decisions that went into current implementation. And Google it, or I will share slides later. Check it out. It's actually very interesting. Building front-end framework in Go. This is logo of our framework. Logo was specifically designed to lower your expectations as much as possible. Don't get excited. It's not going to be production ready. It's not going to be even interesting or useful. It's just a demo, please. So who here actually use frameworks like Vue.js, React.js? Yeah? Who actually knows what is happening behind the scene? Right? Good. Some people actually know. So we're going to go through moving pieces of the framework like that. We need to have some sort of markup format or DSL. React uses DSL that allows you to generate components. Vue.js actually uses markup format that loads, for example, from HTML templates. Right? Then we need to have some sort of state management. React focuses on properties, everything emulated using properties. Vue.js actually allows you to have an external store for your state. Then we need to actually instantiate our component in some way or manner. And then we have magical rendering loop where all the work is going to be happening. So for this demo, let's agree that we're going to actually use Vue.js style of templates. Right? This is template tag, which is standard tag in HTML. Allows you to define markup, and then you can extract markup as a string. Allows you to also kind of walk away from standard HTML spec and do extra things. Right, so in this example, we have two moving pieces. We have computed properties, and we have event handlers. So if property starts from a colon, that means we're going to bind value of some computed property from our component into HTML markup. Right? In this example, we bind label class property into class property of the element. And then we can also inline computed properties as a template in syntax. You can see that we inline count here. All right? So far, so good? Good. And then event handlers. If any property, fridge, stop. If any property starts from @sign, that means, for example, in this example, we're going to bind click handler to onClick event on some particular element. All right? Let's move on. State management we're going to do for the sake of the demo really simply. We're going to have just store structure. That is essentially hash map to the interface, can store anything. We're going to have three methods, set, get, and subscribe. Subscribe is just helper to do explicit notifications from the store to the components that something changed. Please do re-render cycle. Now we need to instantiate our component. To do that, we need to configure our properties in some way. We need to also configure our event handlers. We need to subscribe our component to updates from the store. And then we need to generate tree of elements. Instantiation of the component. So we're going to, computed properties and handlers going to just be hash maps of string to function of some sort. Then so first we're creating actually our store. Then we're creating our component. We call in subscribe on the component, which essentially allows store to mention to the component, please, your state is changed. Please do rendering cycle, figure out difference, do the magic. Then we mount in our component to some element by ID in the real DOM tree. Right? Properties, hash map of string to function that returns string. At this example, we're just going to always return from all properties string, just not to deal with type conversion and for the simplicity's sake. In this example, we have two properties. One is called count, another is called label class. So you can see that in label class, we're going to the store, we're getting counter value from the store, we're casting into integer, and then if it's even or odd, we just return a different string, right? So far, so good. Do I need to slow down? Do I need to speed up? Do I need to start dancing? Oh my goodness, so much pressure. Same goes for handlers. Difference about handlers that our function gonna receive one value called event of type gs.value. This is type that is coming from syscall/gs package. And this is just structure that represent every single thing you can get from JavaScript, right? This is fun thing of interop, doing interop from statically typed language to dynamic language, because dynamic language doesn't care what you want, and you actually need to care, right, in your static language. In this example, we're just gonna bump counter by 1. We're gonna get counter, cast it into integer, increment it by 1, store it back into our store. Yeah. Subscribing component to updates. So when we call subscribe, we simply append our notification channel from the component into list of all notifications for this store. For each set action, we're gonna set value for the key, and then we're gonna try to, for all subscriptions, we're gonna try to put value in our channel. This select statement is there in cases nobody is listening to our channel, so we don't deadlock, right? We just do nothing, essentially. Otherwise, we try to put true value into our notification channel. Now, we have to generate tree of elements. To do that, we need to fetch our HTML markup from template tag. We need to parse it. Then we actually need to create dynamic attributes and create event handlers because before we just configured them. We need to do some extra wrapping around to make them tick. This is how we actually can access HTML content of the elements. So you can see at the bottom example JavaScript, and at the top exactly the same thing done in Golang using syscall.js package, right? So what we're doing, we're calling global function of JS package, which returns us JS value, surprise, surprise. Then we ask in JS value, can you give us property called document? It returns JS value, surprise, surprise. Then we're calling getElementById function on the document, which returns JS value, surprise, surprise. And then we extract an inner HTML property and converting it to string. Since big chunk of syscall.js package is implemented on JavaScript, conversion actually happens on JavaScript according to JavaScript rules of converting every single thing into string in a totally different manner. So this is the moment where your Go code kind of gets polluted with semantics of JavaScript. To parse HTML, we can use simply net/HTML package, right? Somebody used the net HTML package? Somebody parsed HTML?
It's not brave.
Yeah. All right. So we have to create reader out of our string and give reader to HTML tokenizer, right? We create a new tokenizer. So what tokenizer allows us to do to ask, give us next token. And then we're going to look at the type of the token. So for example, if we see start tag token, that means we see actually opening tag of the element. So what we have to do, we have to extract type of the element that we're using. Let's say it's div, let's say it's p, let's say if it's a anchor tag, right? Then we need to iterate over properties and convert properties into something that we're going to use later, right? And then do exactly the same thing for all the child elements of our component. Whenever we see end tag token, that means this is a closing tag. We can just simply say our configuration is done. Please, this is our newly created element. So we actually, element in that regard can be viewed as something React calls component, right? In React, everything is a component, right? In our case, we're going to call it element, but everything is kind of reactive element that's going to be reacting to changes from the store and going to do rendering. Now we have to create dynamic attributes. So we're going to just simply iterate over all attributes and just look at the key. If we see the key starting from a colon, that means we need to create a thing we're going to call dynamic attribute. We're going to have dynamic and static attributes. Difference is for static attribute, we're simply able to return key or value. For dynamic, we're actually returning key and then evaluating the value, right? Value is going to be function. So we're going to look up function in component computer properties based on the key name, right? We're just handling, moving lambdas around. So far, so good? Please just nod. Please. Thank you. That's good. We have to do exactly the same for event handlers. Again, we're going to take a look at the name. If it starts from an @ we're going to strip this @ and use this as a key. Going to look up our new handler, and then going to do a thing called new event callback from JS package. What does it do? What does it do? We actually need to wrap all functions to make them tick on JavaScript side into some magical thing, right? We're going to also tell it prevent default, which standard thing in JavaScript, right? People familiar with prevent default in JavaScript in the browser? Good. And there's an edge case. Text nodes are going to be represented differently in our tree. To do that, we're going to simply look over all computed properties and using regex look up if this property is actually inlined in our template. Right? If yes, we're going to create new dynamic property. Just carry on. Now, actually, main thing is happening here. Our rendering loop. We're going to start rendering loop. We're going to generate virtual DOM representation of our element tree. We're going to apply difference. We're going to compute difference between previous and current version of VDOM, right? And we're going to generate a set of changes. Then we're going to iterate over changes and apply them to real DOM tree, right? So this is main idea of frameworks like Vue.js or React.js. It's very expensive to talk all the time to DOM tree in the browser because it forces browser to do a lot of repaint cycles, recalculate CSS properties, recalculate how everything is aligned, et cetera, et cetera. So idea is we do it in memory and we minimize amount of interactions to the DOM. We're not even going to look up ever into real DOM tree trying to figure out are you consistent. We're going to hope that our implementation is actually applying changes in deterministic way to real DOM tree. Right? If it doesn't, well, happens. So to start render loop, we need to do initial render just to drop something for the user to see on the page. Initial render also going to create first version of virtual DOM for us. And then we're going to iterate over notifications from our store. Right? And we're going to create new JavaScript callback that's going to again do render2 call, but it's going to schedule render2 call using request animation frame function. Again, this is as fancy as it gets. This is what React does. So request animation frame allows us essentially to tell browser we want to do some sort of animation calculation or some sort of manipulation with DOM before next repaint actually happens in the browser. If we would like to do it more efficiently, actually request animation frames tells us number of milliseconds that we have to do execution of our logic, but we're just going to ignore it and look at it. Just don't care. Just whatever. How are we going to diff versions of VDOM? Right? We're going to handle, for the simplicity's sake, because I see people yawning already in the audience. For the simplicity's sake, we're going to handle create and update changes only. For create change, that means we don't have any old version of the virtual DOM. That means we don't have anything in real DOM tree, right? So we need to generate everything from scratch and just insert it again. For update change, we actually need to iterate over properties and see what needs to be deleted, what needs to be updated. We're going to only update properties if values change, right? There is no point, again, resetting property that is exactly the same. Right? Small optimization we can do. How we're going to apply changes for create, we're just going to simply do append child on our parent node. Right? For the top level element, parent node means actually our root that we are mounting into. For any other element, it's DOM representation of the previous element. Right? We're always dealing with a tree here. For update, we're going to simply iterate over a list of attributes that we need to delete called remove attribute. And we're going to iterate over all attributes that need to be updated and call set value on our DOM element. So update for the text node. It's again edge case. Jesus, it was so nice, right? Until this moment. And now text node. So for the text node, we're going to simply iterate over all properties. Going to create regex that represent essentially double opening curly brackets, name of the property, double closing curly brackets, and replace all of those occurrences with a value. As simple as that. Not going to try to be fancy here, not going to try to optimize, just like if it works, it's great. And then going to reset text content of the DOM element. Demo time. Fridge. So let's go and actually try to do a demo. We're going to compile it. takes a bit longer than hello world. And we're going to actually run it. Yeah. I told you. No. Wait. I told you it's going to be underwhelming. So we have actually 3 components, each attached to independent store. So the moment I click the button, we're going to increment our counter by 1, and magic happens. So for odd number of clicks, we're changing background to the black one. Otherwise, we're using white background. And actually, to showcase that I'm not cheating and not just using React.js, we're going to pop up console. And you can actually see all the diffing happening, and we're comparing properties, and we're doing some stuff. Yeah, I told you it's going to be underwhelming demo. I delivered on the promise, at least. So what is not implemented in this demo? We don't support nested components. It's quite trivial to implement. We just need to have some register of components, do lookup, and render it in an element. Again, idea is to have one element tree and always deal with the tree component is there just for initial configuration. Right? We don't support any branching in markup. Can be done using custom element type that actually does branching and returns different versions of element tree. No loops in the markup. You cannot iterate over some sort of a slice. We're not handling remove nodes or change of order of nodes as optimization. This is kind of tricky to do. React does a lot of magic in that, but it's also possible to do that in Golang. It's just question of time and patience. And probably we don't handle a lot of edge cases. So what about Golang on WebAssembly? It works, kind of. It's not perfect. But it's really easy to get it up and running, so please give it a try. And that's it for me. Thank you. And I guess we have time for questions.
So what happens when you don't handle those edge cases? Like, what would the users see?
Ideally, like the big chunk of any front-end framework like that, you want to be deterministic when you do changes to the real DOM, right? The moment you're not, your representation is memory gets outdated with what user sees, and then you see bugs like old versions of React had a lot of issues with like any sort of animation, right? It would just get delayed, timed out, and it's just inconsistency.
How would you differentiate this between a program written in Go transpiled to JavaScript?
Sorry, say again?
How would you differentiate this between like a program in Go, which is transpiled to JavaScript, and then run on the client side?
So what is the difference between like transpiling into JavaScript and actually running WebAssembly?
Because like, as I understand it, like if you do it WebAssembly, maybe you have like speed improvement, but if it's in JavaScript, like I'm guessing the size will be the same as a normal JavaScript file, so it won't be that large.
Yeah, that's true. So again, probably with the next couple of releases of Go, binary size for WebAssembly gonna be reduced. They also had some issue that in general binary size got increased with the latest release because how they handle pages on a disk or something. I don't remember details. How it compares in terms of execution. So problem with the transpiling to something, you have to deal with the semantics of your host platform, right? WebAssembly is statically typed host platform. It compiles to native code. So it's much closer semantically to JavaScript, right? If you would transpile Golang to, like you transpile any language to JavaScript, right? You either allow a language to be changed and polluted by semantics of JavaScript and just say, this is the nature of the language now, or you actually create some wrappers to just make sure that you don't let semantics of JavaScript leak into your language. Ideally, idea of JavaScript, again, was to have something that is faster to execute and parse with, compared to JavaScript. JavaScript is quite slow, mostly because of semantics of JavaScript. Again, like we're reaching the limit what JavaScript can be optimized towards at the moment. Go.
So what's the future of the Go WASM project?
I think it was like 1 or 2 really crazy people just who contributed this to the compiler. I honestly don't know. I think there's a small community revolving around that. I saw a couple of projects popping up on the GitHub. in regards to do something with WebAssembly support, but it's very early stages.
What's the tooling around debugging something like that? So that
Uh,
I know JavaScript that within the ecosystem there's hot reloading, so you have those kinds of tools. How would you debug something of that nature, compiling it and seeing your changes? Is it just a bunch of print statements?
So at the moment, there is no tooling, right? I don't think you can even do like breakpoints in WebAssembly. There is no source mapping between your Go source and actually WebAssembly file. So there is a thing, magical thing called fmt.println. So no tooling really. Right, so you're probably gonna print state and just see what's happening. Helpful thing is that you actually get proper Go stack traces from WebAssembly, so that helps.
So if I wanted to do something like input validation and share that between a Go implementation and client side, is WASM something that I could, like, that in theory, if I like added as a library, I could share it that way and then call into it with JavaScript and that kind of thing?
Yeah, it's like on point. This is actually what you can do. Ideally, like you create some sort of abstraction, let's say interface, right? And then you have two different implementation, one for the backend, one for the front end, right? Because again, syscall.js will not compile for the backend because build flags explicitly say don't compile this on the backend, right? So you need to actually separate using build flags, but it's possible. It's another benefit. You can run your tests for your front-end code, let's say, without any WebAssembly, right? Just run them as a normal Go test, and then once you compile to WebAssembly, you do some replacement magic for implementation. That's it. Thank you.